Okay, so now let's see this question. In this question, they are saying that consider the first order predicate formula phi, where they are saying that for all x, and this huge sum statement is given, where a divides b denotes a divides b obviously, where a and b are integers. Then they are asking consider the following sets s1, s2, s3, and which of the above sets satisfy phi. So let's, for all x, when they are saying that for all x s1 is that satisfying, for all x s2 is that satisfying. So in that sense, essentially they are asking is that, do you understand this statement? And once you understand this statement, you figure out that they are applicable on every element for this particular set or not. Okay, so the point will be to understand this statement. Okay, so we'll start with this. For all x, for every element we are checking that if every for all z divides x, so anything which divides x, then it implies only one thing: either x is that number or or z is equal to 1. So it means that what they are saying, that anything which divides is either 1 or x. It means either 1 can divide x or x can divide x. What do you remember anything like that? Yes, that is a prime number. Prime number is one such thing to which only that same number divides or 1 divides. In that sense, we are going to have a prime number. So, okay, so this entire thing is saying you that x is a prime. Okay, so for all x, they are saying that if x is a prime, then it implies something this. So this entire thing is the second part, right? So if x is a prime, this should imply this. Okay, what they are asking about this, what should imply? It should imply there exists w is greater than x. So there should exist some number which is bigger than x, which is bigger than this prime. Okay, and at the same time, this w is also a prime. See, again, for all z divides w, so anything which divides w, it only it can be 1 or 1 or w. It means that only that number divides it in w, or 1 divides w. It means that w is a prime. So essentially it is meaning that if we are having z, if for all x, if that x is a prime, then there must exist another prime which is bigger than that prime. Okay, so what is the bottom line? Bottom line is that if x is a prime number, then there must exist another prime number in the set which is larger than that previous prime number. That is the entire meaning of this statement, right? So it is a too much complicated looking big statement, but this is the boiled down version of that. Turns out that when we are trying to figure out, this is definitely only true when we are having infinite sets, something like set of all integers or set of all positive integers. So if any prime I give you, you can always find another prime in that infinite set which is bigger than that. If I give you again this prime, you can find again another one bigger than that, right? That is the entire point of sets like all set of all integers or set of all positive integers, like. So this thing will be satisfied in s2 and s3 and will not be satisfied in s1, precisely because of this reason, because this is a finite set. There has to be one. So let's say 2 is a prime, there is a number which is bigger than 2 and it is still a prime. Yes, 3 is that number, but it cannot hold always, because there must be a, since this is a finite set, there must be a final prime number, which means the biggest prime number. And that prime number in this case, let's say, what is that, 97, right? So for 97, this statement will false. Why? Because for this set, 97 is a prime, which should imply that there must exist another number in this set which is also a prime and which is greater than 97. which is not the case. 97 is the biggest prime. There is no other prime which is bigger than 97 in this set, right? So this statement hold false, which means that for all x this thing does not hold true, which means that S1 does not hold for this first order predicate formula. So what holds true? Which of the following sets hold true? The sets which satisfy phi is basically S2 and S3, S2 and S3. So the correct answer is C.